continuity.
Hello everyone, this is Dr. Speights with math videos on PowerPoint. This lesson covers completing the square.
In this lesson, we're going to determine intervals of continuity. A continuous domain is a set of input values that consists of all the numbers in the domain. In the example below, we see a line graph that shows an interval between 1 and 5. Notice that it is continuous, which means that it includes all real numbers between 1 and 5. A function is continuous over an interval of its domain if you can draw or sketch it without lifting up your pencil from the paper. So if we start our pencil here at 1, we can move all the way to 5 without lifting up our pencil and sketch that entire domain. So therefore, that is an example of what we call a continuous domain. This next example is a discrete domain. A discrete domain is a set of input values that consist of only certain numbers in an interval. So here again we have a graph, and if we were to try to draw this interval of between 1 and 5, to sketch this, we would have to lift up our pencil from 1 to go to 2. Again, lift up our pencil to go to 3. It is not continuous over the domain. The domain of this graph includes only integers. In other words, only these whole numbers here. So these types of functions, they do not include all real numbers and will often have a break or points of what we call discontinuity. Determine whether the domain is discrete or continuous, then describe the interval of continuity for each function. So let's take a look at the first function. We want to know if it is discrete or continuous. So all we have to do is take our pencil, and if we can sketch or draw that domain without lifting up our pencil, and if we do not see any breaks or points of discontinuity along that domain, then it is said to be continuous over the entire domain. In this example, it is continuous from negative infinity to positive infinities. And again, the fact you have these arrows mean that it's going to go to infinity in both directions. So the first example is an example of one being continuous over the entire domain. Let's take a look at the second example. So we're going to start with our pencil, and we're going to come from negative infinity, keep moving on toward positive infinity, and see if we can draw the entire domain without lifting up our pencil. Okay, we come to a hole or break. So in order to continue on that domain, I have to lift up my pencil and continue back up and keep going. So we can see here there is a hole or break at 3, so it would include every number in the domain except 3. And so we can write that either in interval notation form or set builder form. But the bottom line, this function has a point of discontinuity, a hole or break at x equals 3. So it is continuous over the domain except for at 3. Okay, so here we want to again determine whether the domain is continuous or discrete, and then describe the intervals of continuity for each function. So starting with the first function, let's go ahead and begin sketching with our pencil and see if we can go through it without lifting up our pencil from left to right, moving along that domain. We can see that we can sketch the entire domain without lifting our pencil, and that domain extends from, notice here, from 1 to 5. So we would say that it's continuous over its entire domain. And then we have the second example here. Let's see if we can, from left to right, draw or pencil in this one without lifting up our pencil. So to get from one point to the other, unfortunately, there's no other way to get to the other point other than lifting up our pencil if you would try to sketch this graph. So that means that this is a discrete one. It has some points of discontinuity, and so your domain would consist of the points here of 1, 2, and 3 only. Okay,